All right, I'm back. So in the last video, I showed you how to create a window, how to specify how big it was, and we created our ship for our Galaga game. We specified which image to use and where to put it on the screen, and we also got some basic movement using our keyboard. In this video, I'm going to show you how we can get our ship to shoot, as well as getting an enemy in there and starting to have it move around. One thing that I didn't mention before, which you may want to do for your game, is to change the background color. Currently, we just have it being the default, which is black, but maybe we wanted a different color. So what I'm going to do is up here, also we didn't really do any commenting, which you really should be doing. So I'm just going to comment screen dimensions, create our Galaga ship, and then this is, specify initial position of ship. Ship movement using arrow keys, left and right. Now, if we want to change our background color, first what you'd want to do is to, I would set up some variables that create different colors that we may want to use. And so defining colors for a game. So for instance, if we wanted white, now the property that PyGame and PyGame 0 typically use for colors is a tuple or a tuple. Now to define that, we need to use parentheses, and we want 3 parameters: one for red, one for green, one for blue. And so each of those parameters can be a value between 0 and 255. If we do 0, 0, 0, then that will actually give us black. If we put 255 for all 3 of them, that's going to give us white. And since we've got red, green, and blue, let's say we wanted red, we could just go 255, 0, 0, and maybe I will keep that there. Green would be 0, 255, 0. Blue is 0, 0, 255. And I'm also going to go white, which would be 255 all cross, and black, which is 0, 0, 0. Okay. Now we've got some basic colors. If you want to get a specific shade, then of course what I would do is just look up on Google. There are a ton of color code generators. It'll give you the HTML hex color code, but you can it usually will also give you the equivalent RGB values, and then you can just put those values in for whatever color you want. Now, how we're going to use that is down here after the screen dot clear. That's important. After that, then we're going to do a screen dot fill, and screen is a built-in object. I don't know if I mentioned that before. And we've got clear as a predefined method, fill as a predefined method, but it requires a parameter which is a tuple, giving you your RGB values. Since we've defined those up there, all we have to do is put in there white, and then that should fill our board with white. Perfect. All right. If we instead, let's say we wanted it to be blue, well, we can do that. And the cool thing about this is, this may even be a simple way for you to give the player a sense that, oh, I'm on a new level, where you could put, for the screen dot fill, you could put that inside of an if statement, a bunch of if-elifs, and depending on what level they're on. And that way you could even just change up the background color for the different level and give them a feeling of, whoa, I'm in a new level. The play style is exactly the same. The gameplay could be exactly the same, but just changing the color of the background gives the player a sense of progression. And that's actually the way a lot of the old games did it when you moved on to another level. They would just change the background color, and it just, made them feel like a little bit of excitement of like, whoa, I'm on a new level. Anyways, let's get back to shooting. Now, because we're going to have an undetermined number of bullets on the screen at any given time, we need to, we're going to have to make a list to keep track of those bullets. Okay, if we just create a single variable for a bullet, that could work if we're only going to have one bullet on the screen at once. But chances are we're going to want more than that. And so, so that's where we want to have a list, so we can add a whole bunch of bullets into that list, and then we can work with them. All right, one at a time. We can use for loops to iterate through, and we can move each bullet every frame, and we can also draw each of the bullets. Okay, so let's take a look at this. So I'm going to define a list for bullets, and I'm going to make bullet equal to an actor, and I'm going to call it bullet. Now, it may not necessarily be a bullet, it's probably more like a laser for this guy, but I'm just going to call it bullet. Of course, you can name it whatever you want. Now, in images, I don't have an image for bullet, but I actually did have one previously when I made my centipede game. It's essentially a white rectangle. Okay. If you're wondering how I make my my images, you can. I just made them in Piskel. Look it up, Piskel. I'll put the link in the description of the video, and it's a great online tool for making making simple pixelated images. Okay, so what I'm going to do is I'm going to copy that, and I'm going to paste it into the images for Galaga so that I can use that. All right, so now I've just got a bullet image. It's a basic rectangle, and that's how we'll create one. But I actually don't want to make an actor right now. What I want is to make just an empty list, and I'm not going to put anything in it as of yet. Okay, so now inside of update, when do we want to shoot? Well, normally I'm going to make it so he shoots when I push the space bar. You can of course have him shoot when he pushes any other key, and in a future video I'll show you how to check not only about the arrow keys and simple things like a space bar, but pushing any of the other keys, and how to get, you might have to use some Unicodes for the keys, but I'll show you that in a future video. So for here, we're going to do an elif. Actually, I'm not going to do an elif. I want to put this in a separate if statement. And the reason why is we want them to be able to fire when they press the space bar, even if they're holding the left or the right key. If I put this in an elif, then if they were holding the right or left key and they push the space bar during that, it actually wouldn't trigger. Because remember, with an if statement, if you have it in a series of if-elifs, it only triggers the first one that is true, and it will ignore all the rest. But by putting this in a separate if, it's possible that you can hold the left arrow key, have it move your guy left, and hit the space bar at the same time, and both triggers will happen. So if keyboard.space, then I'm going to append into my list an actor of bullet. All right. Now, I also want to specify the X and the Y position. Okay. And so in here, I can actually go X is equal to, and I can specify the X value here. So I'm going to make it equal to X of the ship, and then I'm going to go y is equal to ship dot y. So it's the exact same position of our ship. Okay, and that's it. It should be creating that. Now we haven't told to draw at all, so we won't be able to see it yet. So after our ship.draw, now I'm going to go, now I'm not just going to go bullets.draw, that doesn't work, but I'm going to go for bullets in bullets, bullet.draw, and that's it. Okay. For every item in bullets, call the draw method. Okay. And this works only if every element in our bullets list is an actor with the draw method. If we populate this list with any other values, that'll result in an error, of course, because if it doesn't have the draw method, it's going to be trying to call it there, and that'll give us an error. Okay. We haven't told the bullets to move yet, so in our update method, let's do that. So we can basically do the same thing. For bullet in bullets, we just want every bullet. Now we want it to move up. Now remember, when we're in PyGame, and this is actually true of almost every game engine out there, except for Scratch, of course, but the Y values start at 0 at the very top of your window, and then as we move down the window, our Y values increase. So our Y index is an inverse of what we learn in math, in our math class, with the Cartesian coordinate system. Our X values, though, actually do behave normally, but X is 0 in the top left corner. Okay, so that's where you have to remember, top left corner is coordinates 0, 0. As we move to the right, our X values increase. As we move down our window, our Y values increase. So if we have our bullet starting at the bottom and we want it to move up, we actually want to decrease the Y values. So we're going to go bullet.y minus equals, and let's make it 10 to start. We may want to make it faster later on, but let's just do that to start now. That means every frame for bullet and bullets, if there's nothing in the bullets list, of course this for loop isn't going to go. But if there is, it's going to go. Now let's try running it. We've got Galaga moving back and forth, and we push the space bar. Now notice it's not coming out of our ship, but if look in the top left here, I see it showing up there. Now that tells me that the initial value isn't actually being changed there. So what I'm going to have to do, I wondered if this was going to work, but not. So instead, what I'm going to have to do is bullets, and then I'm going to refer to -1, which should be the last element in bullets. And there should be at least one element because I've just appended it in there. Then I'm going to change the X value there to be ship.x. And then bullets -1.y is equal to ship.y. I could put that in one line, but I decided I want to have them separate just to make it explicit there. There we go. That's more like it. So now notice that if I hold the key down, it's like a bullet hell. And we don't necessarily want that. The problem with that is we're not, it's where we need to change it to an on press event, not the on hold event. And so I'm just going to go back to my Centipede game because I use the exact same thing. And so here we go. On key down, key. If that key is space, then we shoot. And I created a separate function for that. So this is actually a built-in method that only recognizes the key down events, not when we're pushing it down and holding it. All right, so let's do that. Def on key down, and then I'm going to put keys in there. Actually, key. Let's just put key. If key is equal to keys dot space, then that's where we want all of this. Now this is an event that will happen only when we press a key down. It won't get triggered if we're holding the space bar, which means when we push the space bar and hold it, it should actually only shoot once, not constantly. Let's try that out. So there we go. So when I push and hold it, notice it's not doing anything. It's just doing the one. But if I can spam it but it's limited to how many times I can push the space bar. There we go. Notice that it's like, you know, coming out of the middle there. So this is where you could always customize it. Maybe you want to have a pair of blasters, or maybe you want it to come out the front. What you could do is just offset the Y when we create it. So rather than it being just equal to the Y value, we could do Y minus, I don't know, 50, and see if that is closer to the front. Looks like it needs to be a bit more, maybe 90, and that way it comes out the front. You could also have it, there we go. You could also have it where eventually you get an upgrade to twin blasters where they're coming out of both of those. It just leads to a whole bunch of things. Now I was also going to show you guys how to get an enemy. Now for enemies, similar to the bullets, we're going to have more than one enemy in our game at one time. So it makes sense, rather than doing just a variable like our ship, where we only have one, but to have more than one. So let's define a list for enemies. So I'm just going to call it enemies equals an empty list, and to start with, let's append into our list an actor, and I've created one image is a bug. So let's put that guy in there, bug. All right, and let's, similar to our bullet, let's set its X equal to, well, let's put him in a random location, shall we? Let's go from maybe 40 to width minus 40, a random location between there, and let's change its Y value. Now I want him to start off the screen so that after he's there, then we're going to have him move down. So I'm going to make him start at negative maybe 100. Okay. So let's start there. Notice that if I'm importing if I'm using random, I need to add in the import at the top. Okay. So I've got that. First thing I want to do is I want to make sure that I'm also drawing my enemies. So for enemy in enemies, enemy dot draw. Now we should be able to see him, but he'll be off the screen, so we won't be able to see him yet. So we also want to get his movement going. So similar to bullets, in bullets, I'm going to put an enemy in enemies for loop here. So for each one, I want it to move at a constant rate to start with, and I'm going to move them just straight down. Now to move them down, I'm going to actually increase the Y value. So enemy dot y plus equals, and let's go with, well, 20, let's say. So it's moving at a pretty good pace. Okay, let's see how that works. Whoa, now that was a big bug. Now, clearly, I need to resize my images. All right, I believe there is some really basic scaling options in PyGame 0. To be honest, I would recommend you change the size of your images outside of PyGame first. Make them small. That also lowers the size of your game overall because the resources you're using take up less pixels. And it requires less processing power in Python to be scaling your images in the game. So in the next video, now just to show that the randomness works. So he's coming down, and right now it looks like he's roughly in the similar position, but it should be somewhat random. There he is. He's a bit more to the right now. We haven't added any collisions yet, so even if I shoot him, it's not going to do anything. Also, when he gets to the bottom, he doesn't disappear, and our bullets aren't disappearing either. They're just continuing going. All right. So that's something else we want to think of. If the more we shoot, the more bullets we're going to be adding into that list, which means it's going to be increasing constantly. All right. They're not getting removed. So another thing you're going to want to have to do here is in here, what I would do is put an if statement where we check if bullet.y is less than, let's say, -20. That means it's gone up and it's already out of the screen. Then bullets.remove bullet. All right. So that way, and then we're going to put the changing of the y in an else statement. That way, for each bullet in bullets, it's checking every frame. Is it out of the screen yet? If it's out of the screen, let's remove it from the list. If it's still on the screen, we're going to move it. All right. For the enemy, what we can do here is if I'm just going to put in a condition right here. If enemy.y is greater than height plus 60, then I'm going to change my y value to be back to -100. So it just is basically looping back to the top. Okay, and at that point, maybe I'll set my x again to be a random location, so it doesn't look like it's just caught in a loop necessarily. Just before I go, let's just test that out. So now we can see we've got an enemy coming down, and notice how when he overlaps me, the enemy is on top. The reason why is because we told the enemy to be drawn last, whereas my ship was the first thing that's drawn. You also want to make sure of that. That matters. If you put the screen fill at the end, then all you're gonna see is a blue background. Whereas if we put at the beginning, then everything, it is going to truly be just a background. Everything else is going to get drawn in front of it. But if we wanted our ship to be drawn and it to overlap everything else, all we have to do is have it draw last, and everything else will show up underneath it, just like that. Okay. For the next video, I'm going to introduce collisions, so you can have the bullets collide with the enemy, and then we can have it disappear. I'm also going to shrink my images a little bit, just so it's a little bit more manageable. All right. But thanks, and happy coding.